everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over finding the x and y intercepts, specifically for when we are dealing with standard form. So it's very important to be able to find our intercepts, but we must know what an x-intercept is, what a y-intercept is, what is standard form to even be able to complete this. So let's start off with our vocabulary words. So our key two vocab words here are x-intercept and y-intercept. So an x-intercept is just like what the word sounds like. Doesn't intercept kind of sound like intersect? So it's where the line intersects the x-axis. So it intersects the x-axis. Let's say we have our coordinate plane. It intersects our x-axis, let's say over here. Well, that's when our y is 0. It's important to note when we're given a graph, we'll look where it intersects the x-axis. However, what if we're not given a graph? We're just given an equation in standard form, no graph paper to graph it. We are going to want to know what we do. So what we do is we see our y is 0, so we plug in 0 for y, or I'm going to show you, we can just cover up that y, and you tell me what the x term is. For the y-intercept, that is when, once again, it crosses or intersects with the y-axis. So the point at which the line intersects the y-axis is the y-intercept. Specifically, though, that is when x is 0. So it's a way kind of flipped where you say x-intercept, oh, that's when y is 0. Y-intercept is when x is 0. So these are important points to realize what these terms mean, because if you flip them, then you're going to get the wrong answer. So x-intercept, y is 0. Y-intercept is when x is 0. So how do we do this? So it's easiest to find when it's in standard form. So recall I said we want to do this in standard form. Well, standard form is ax plus by equals c, when our a, b, and c are all not fractions. They have to be integer values. So we are given in this form, and then we're going to apply like we just said. So my x-intercept, I'm going to plug in y for 0, and then I'm going to solve for my x value. Same thing for the y-intercept. I'm going to plug in my x as 0 and solve for my y. So let's take a look at a problem and see how I would complete this. So I have 6x plus 4y equals 48. I'm going to start off by finding the x-intercept. So the x-intercept, I like to write down what I'm doing. The x-intercept is when y equals 0. So there's two ways to go about this. I like to think my x-intercept, I'm solving for x. My y term goes away. But let me show you the mathematical reasoning. 6x plus 4 times 0 equals 48. What is 4 times 0? 0. So it just goes away. That's gone. So it's almost like I'm taking my y term, I'm covering it up, and I'm left with 6x equals 48. Now I divide by 6. It's a one-step equation, and we can all do our one-step equations by now. So I divide both by 6, and I get x equals 8. So my x-intercept, my x value is 8. My y value is 0. Now let's find the y-intercept. My y-intercept is when x equals 0. And I can plug in 0 for x. And I'm solving for y. Y-intercept, solve for y. So 6 times 0 is 0, so it's gone. Once again, it's like I covered up that 6x, and I solved for y. So I get 4y equals 48. Once again, a one-step equation, so I divide by 4, and I get y equals 12. I'm going to write that as a formal point. So my formal point, my x is 0, my y is 12. If this was in slope-intercept form, you would have y equals your slope, x plus 12, and then you can find your x-intercept if you want it from there, but we're just focused on standard form for today. Let's take a look at another problem. So now we have this problem, 4x minus 3y equals negative 6. I'm going to start off again with my x-intercept. So my x-intercept, I'm going to do it the little cheat way. My x-intercept means I'm solving for x. So I'm going to cover up that y. It is gone. That y term is gone. So I'm going to do 4x equals, because that's gone, negative 6. I divide both sides by 4, and I get x equals negative 6 divided by 4. We always simplify, though. We want simplified fraction form. So I'm going to divide both by 2, and I get equals negative 3 halves. So my x-intercept, my x is negative 3 halves. My y was 0, right? It's gone. And that's my answer. My y-intercept, and once again, is when x is 0. So I cover up that x term, and I'm left with negative 3y equals negative 6. I divide both by negative 3. Divide by negative 3, divided by negative 3, and that leaves me with negative 6 divided by negative 3. Well, negative divided by negative is a positive. 6 divided by 3 is 2, so my y equals 2. We divided both by negative 3. So my answer is going to be 0, 2. We're going to try one more problem just to make sure we're all fully where we need to be with this topic. For our last problem, we have negative 5x plus 6y equals 20. Once again, I'm going to start with my x-intercept. My x-intercept is when y is 0. I'm going to cover up that y. And I get negative 5x. I plugged in 0 for y. 6 times 0 is 0, so I'm gone. Equals 20. I'm solving for x. X-intercept solve for x. So I get x equals negative 4. So my answer is negative 4, 0. Now I'm going to do the y-intercept. Y-intercept is when my x is 0. So I'm going to be solving for the y. The x term is gone. Negative 5 times 0 is 0. It's gone. So I get 6y equals 20. Divide by 6. And I get y equals 20 over 6. But once again, we want to simplify. So I'm going to divide both by 2. And I get 10 over 3. So my y is 10 divided by 3. So my y-intercept is going to be 0, 10 over 3. We have to make sure that we're writing it properly. If we have an x-intercept, we're solving for x, so it means our y is 0. Our y-intercept means I'm solving for y, so my x is 0, and I write it as a proper point. I hope this was helpful for being able to determine how to find your x and y intercepts in standard form.